This is the second day of our Cimatron 2026 global version presentations. Happy to be here with you and great to see all of us together. Yesterday, you've seen lots of functionality, many of that in a higher level. And today, we are going to cover everything on the technical ground. The product owners and Alon will go deeper into the functionality described yesterday and some more. Starting with CAD and applications by Danny Branch. Uri will talk at length about the Excel integration and show you many details on how to use it. Maoz will cover again the CAD AI Copilot and related topics. And of course, the CAM side with Gili going and showing us into the functionality and Alon covering the additional implementations. You're invited to comment or ask through the chat, and we will, of course, read the questions and to answer them.
Hello.
Hello. So we can start. So Danny, you can show your screen and begin with the CAD features in version 26 in detail.
Thank you, Guy. Screen should be showing. Let me know if the volume's not good. And hello, everyone. Yeah, I'm Dan Branch. Thanks for being here again with us. We're going to talk in greater detail about the CAD features and review what's new, version 2026. And I thought I'd start with the big picture. This is it. This is what I consider to be the highlights of this version in CAD. And it's a pretty big list for a list of highlights, but it's not, I didn't just dump everything here. There are other features that aren't here. You know, you can always read the What's New document to find out all the little details. That's there for you. If you did have a chance to be in the introductory meeting yesterday, I did start with the same list, but today is when we really have the time to go over each highlight, share a little technical data, share some tips that I think you should know, probably a few things that aren't in the What's New even. In fact, Guy just showed you the agenda and he has given me over an hour to talk. So buckle up. It's a lot of time. I hope you don't feel like this section goes on forever, but I am excited about version 2026. And that's why we're here, to talk about all this stuff. So like I said yesterday, I do like how balanced our version is this year in every item. So from regular modeling and Sketcher, which we expect, but also the applications like drafting mold, die, electrode, everything has something on this list. We made some good improvements everywhere. And I did mention this yesterday too, but we had a lot of feedback on this list. That's how they got here. We had functions to finish from previous versions. We had our new pressure. We had the TRT. Thank you, those who help us with that. And we're even listening to some selected strategic customers, some big customers who have some needs they want to impress upon us. So of course we want to do as much as we can from all of that, but we have to filter it down. That's the reality. We came up with this list, and that's what we can do in a yearly release cycle, which is what we're doing, right? 2026 is the third in a row release time to the calendar year. We're getting pretty good at that process, allotting our time, planning, coding, and testing. So here we are, and let's start at the beginning. modeling. We all know Cimatron has a really good foundation, good modeling tools, right? But we keep trying to make them better. So fillet is one example of that. Just want to get into that. The function requires that the groups of faces be connected edge to edge. And when they're not, we've always shown you this warning window. Hey, there's a gap found. Okay, great. Where? How many of these edges are a problem? Where are they? You don't know. So we kind of thought that was something we could improve on, especially seeing as how usually there are tiny, tiny, small gaps and they're really hard to see. That can waste a lot of time when you're looking for them. So in a little better way, in 2026, we're going to show you the message plus highlight the edges that are causing the trouble. It's going to help a lot. On the technical side here, this was actually pretty difficult to do. I was surprised. I thought we'd just know where they were, but it requires measuring and a lot of actual work. So to keep it from being a performance drag, we had to limit ourselves a tiny bit. I will say that the really large gaps, we're not going to highlight. There's a certain threshold over which we just give up on the measuring, and that's fine because the really large gaps, those weren't the tough ones to find anyway. They were obvious. Similar improvement in loft, small improvement, because quite often this function works fine, most of the time. But once in a while, there could be some alignment issues with the sections. And when it happened, there was no good way to fix it, except maybe try chaining the curves in a different way. And that's a rabbit hole. It spends a lot of time. You might get nowhere. So we took care of the problem by adding some controls. One is direction control, actually. In the main step, you can flip the arrow one way or the other, but we also added this start point control. So between that and the direction, those two options, you can fix anything that's going on with the loft, or you can even play with it and change a few things to affect the end shape you're getting. And now this one. If you did attend yesterday's overview, you heard me mention it. In this version, we tried to tackle several challenges relating to user intelligence and automation. The good users are doing that and they want more of it. It just fosters a good Cimatron community. Everything about it is good. So we have a number of features that touch on that. This one is related to formulas and catalog parts, because it's very common to see that some of the parts being driven in the assemblies are catalog based, very common. But when the catalogs get changed, whether it's our update, the user, whichever, the parts want to do an update. And that type of update is not mandatory. Users can ignore it, but we've all seen they don't like to, right? They see those red marks in the tree and they want to resolve that, so they do an update. They just can't help themselves, and then all the formulas get dropped. That is no longer going to be a problem. We're no longer going to toss away that intelligence, make people redo their master assemblies. We check the part that's based on the catalog prior to the update. We store everything in it. We go ahead and do the update like we have, and then we reapply these formulas. Should be a good feature for us. What else? We started working on some popular requests in the CAD infrastructure area. And there's a lot to that. There's always requests in this arena, but what we started with was rerouted features and everything to do with them. So I think personally that Cimatron has always been very smart about how we handle lost references, which is what a reroute is, a dropped reference. We don't make a big deal out of it. It's not a crisis. We freeze the lost reference and the user can worry about fixing it if he wants to. And that served us well for a long time. But the thing is, some users want to fix them. And those users have always been requesting a better reporting for rerouted features. So reporting is what we can do here. It's important to note that this is a nice project, but it can't change the way you fix a rerouted feature, because that still requires an edit. You know, you have to get in there and do some sort of reconnect on the reference that was dropped. Only the user knows how they want to handle that. We're just trying to make it easier on them. And we're doing that by giving them the information that the system has on the lost reference, everything that we can. So we improved the tree marking. That's one of the things. You've always seen these little broken symbols when it comes to geometric references. We never bothered to show you another type of reroute. We use the same word, but it's a dimensional, in other words, formula-based reference. In other words, when a formula goes red, maybe you've seen that. Anything to do with dimensions is a reroute too, and now we show those, which is great. We also went ahead and added that into our search. The search bar already existed in the tree for a few things, and now it can do reroutes as well. Part or assembly level, it'll highlight them and help you find them. I'll show the last picture, but I want to say it again. We still don't want to insist that all the users get super worried about rerouted features. That is not the intent of helping in this area. They're going to keep happening. It's a natural part of design, and for the most part, they're okay. But we have made a new tab in the tree called Reference Manager, and it can be turned on or off by preference. And that's because, I hope some users don't want to mess around with this. They may not want to see it. It is a limited feature tree. Only the rerouted features in the part are shown, and you're going to see those columns there. The type of reroute, whether it's based on geometry or a missing parent. You're going to see the source of it, whether it was internal or some part external. And then the detail is everything we can get out of the database to show you. It's actually not as much as you might think. We had to actually work on it and improve it. But if it's a drop plane or whatever reference it is, we'll try to show the user here. And that's the project. It's a good start. I hope that's going to be popular. This next slide, you probably noticed for the last few versions, actually, we've been adding some tools in regards to volume and mass. So when we add new stuff, we tend to get comments back and we improve. Everything about it is done in the information tool. And one thing about the information tool, it creates a lot of pop-ups. If you've ever used box pick in here, you've seen it creates thousands of pop-ups. But that's okay. You can hide those dialogues. I hope people do. Anyway, in the function, there are buttons to store the total volume, the total mass. But if you wanted to store them individually for the parts, you were stuck with clicking in the boxes, and that's a lot of work. So that led to this new button here, which saves the volume and mass attribute for each individual part, but in one click. Much better. And while we're talking about it, I will mention that we added the calculation for open objects here, which it couldn't do before. Only measuring did that. We needed it if we're going to use this as the spot to fill in the attribute. And we're still working on performance. So far, volume and mass calculations take a lot of time. It's a calculation that has to happen. So if you do pick a lot of parts, yes, it can be slow. We're trying to figure out how we can make that better. Let's move over to Sketcher. Yeah, a couple small things in here. I like them. They're good things. For example, creating geometry. One of the ways I like to use it is, right click and apply an extra constraint. If you know it's going to be normal or tangent, you can do that. Do it all the time. But there were a few odd situations. One example would be like a line from a point, and then you want to make it normal to the same line. And it wouldn't work that way. It was just about some rules, which made sense, but they could be annoying in certain cases. So we changed those rules. And now you'll find it easier to make predefined references in some of those logical places like that. again, in this case, another thing we did that just makes things a little easier regarding adding constraints afterwards. You couldn't box select while you were in this function, but you could box select and then go into the function, and that didn't make any sense. Obviously, it was okay, so we opened up multi-select. You'll find that you can't apply everything when you're doing multi-select, but we did open up a few like tangent, so you can do a bunch of those at once. Nice in certain situations. And then a bigger project was a new check, a check for self-intersections. And here's why we did it. I don't know if you've ever been extrude or maybe a few other functions, but you'll see a pop-up like this. Oh, sorry, your sketch is self-intersecting. Well, that's frustrating. Hold on, lost my mouse. There we go. And we thought we could do better. So there's a preference that we've added to run a check before you exit the sketch. Warn about self-intersections. I think it's on by default, which is good. That check runs not all the time while you're sketching, but only when you go to exit. And if you want it to work, it just checks the sketch and will say, hey, your sketch has a self-intersection. You can say continue, maybe it's on purpose. But if it wasn't, for cases like when you've added some edges from surfaces and they're real tiny problems that are going to come back to hurt you later, now you'll know right away. You don't even have to leave the sketch before you fix the problem. Good enhancement. And one other thing for sketch in regards to saved sketches. They're a cool idea. They've always been there, but I don't know a lot of people that use them. If they were good, it would be a cool way to have like a 2D catalog of things that you can modify later. And they do hold dimensions, but up until today, they could not store any formulas, which made them a little dumber. And that gets back again to what I mentioned about helping people with built-in intelligence, right? Giving them ways to make the system more automated. So in 2026, formulas and saved sketches will be saved. And for the most part, right? In the technical meeting, we get to talk about the limitations. So let's do that. There are 3 examples, really. Here's one. If you're making a formula and a sketch to another dimension in the same sketch, never going to be a problem. These are now saved because the dimension that it's referring to is known. We got that done. But well, I better back up one. There's another type of dimension link, and that is in a sketch to some dimension outside of the sketch, which is fine in a part, but we are not able to save those in a sketch, guys. Imagine you place this in some other part, some completely other part, and that dimension link is going to be to something, who knows how different. It's just not feasible to do it. The good news is there's a third kind of formula, and those are the ones that we make in a sketch to set up. And yes, we came up with a way to save those. They're saved at a string level, because if we save the internal ID, that wouldn't help. But when you place a sketch like this in another part, we're going to look for the same setup table, the same group name, same row name. If it finds it, it's going to link right back up. So stuff like setup die progression, that's a standard one. Yeah, no problem there. And what's even cooler, we thought, okay, what are we going to do if the link isn't found for whatever reason? Well, you know what? It's not going to drop the formula. It's just going to add that line into your setup so that it can still be used. All good. I think we can do some neat stuff with this. And I think the users will find ways to do neat stuff too. All right, environment. Let's talk about the system in general. Some projects for sets. A few of them are simple. I'll mention it. We changed the light bulbs. Hardly a big deal, but consistency of the system is important, and it was using the old ones, so we had to do it. Another thing we had to do was finish up the folder support. So set folders have existed think people are finding them handy, but they didn't transfer between certain types of operations, like export to NC. Bad. So we finally got around to getting that done. Anything that's file related, import from part, export to part, folders should be all good through all those kinds of transfers. And the other picture here on the right is a picture of the preferences in the manufacturing attribute area. It can make sets. It always has, but the names were a little weird. I don't know how that happened. So it was almost a bug fix to fix the names, and we made a choice, and while we were at it, we added in the folder. So you can get the simplified or long name for the set, and you can say, oh, I want them all in a attributes folder or a folder for each type of attribute. All your choice. That's what preferences are all about. But the big project for sets was this. Which completely changed the way criteria can be selected for assemblies. Because up until now, there weren't many useful criteria. There were two, color and subcategory, one attribute. And there were a lot of calls to do more. So we took the opportunity to just remove a few lines from this dialog that assemblies weren't even using anyway. And we took the space and we added the controls, so that you can now select any part attribute to become an assembly set criteria. Even user-defined ones, which is super important for those strategic customers I was talking about who want to customize the system. Now there are 3 new rows here, right there, part attribute, relation. Once you select an attribute for the set, you do have to pick the relation underneath it, like equals or contains, something like that, and then the value. And actually, depending on which attribute you're using, you're going to see the relation and value choices change, because some attributes are just checkbox, true or false. Others have strings values, so it's very smart. It knows what to do with each attribute. Overall, it's really great. I think we've finally found a way to make those assembly sets useful, like they always should have been. To go further into this, of course, you can still do things like have multiple criteria for a set. The dialog window still expands, and you can show and see the multi-criteria that you're applying. I should point out that it used to be a checkbox. Now it's an icon to expand it, but that's standard Cimatron behavior. The checkbox, which is still there, you see now it says ignore subassemblies. So I want to explain what that is about. Parts aren't the only thing that have attributes. Subassemblies have attributes too. So if you're making a set by attribute and there are subassemblies, we have to know what to do. The default behavior in the system was that if the subassembly had the attribute, then all the parts in it would too, which is fine in some cases. Like maybe it's an ordering attribute and you know that you want to order everything in that subassembly. But it's a little weird to say I want a set of all the things that Bob worked on and to see parts in it that weren't parts Bob worked on. That was because of the subassembly effect. So you've got the choice now to turn that on or off, okay? Basically ignore subassemblies for that attribute. All of it seems to be working good, but we'll get a lot of feedback on this too. Also, no old sets, no problem. I know we changed the way we make the new ones, but it's not going to affect anything in any of your old assembly files. Still working on the environment area. We added a new button in the dialog for dynamic section. And you expand this to see the area underneath. Actually, there's 2 icons now because the one button that existed was word-based, which meant it had to be translated. Now it's a picture for the intersection curves. And the new button is called Save as MView. You can use it anytime you're in a dynamic section that you like and click it. It creates an MView of what's on the screen, the orientation on the screen, and the section on the screen. That's all typical MView stuff. It happens fast, so we do a little fading pop-up in the corner to confirm it. That way you know, but you don't have to click OK. It gets a default name. We don't stop and ask you a lot of questions on this. So you'll see it in the MView tree, but you can go back. It's an MView. So if you want, you can edit it, rename it, do whatever you want to it. Obviously, it will be a section MView because you made it out of dynamic section. And I want to say this, even though it's probably obvious, it's once you make the MView, it's not related back to dynamic section. If you go there, you're just in the MView. It's not like you're in dynamic section and MView at the same time or whatever. Very handy for modeling, but MViews have the added benefit of being handy for drafting too. So it's like a new way to save a simple section view. Oh, sorry guys, gotta back up. My mouse in the wrong place. Okay, data management. We have a couple things to talk about with file archiving. We added a new option to unpack. One small checkbox, but I think it's super useful because a lot of times when I get a CTF file, I put it in a deliberate place, right, where I want it. But then I go to unpack it, and I always have to browse to where I want the files to go, which was being the last used folder. That's a good default, but it's not where I had the CTF. So now with one click, I'll be able to just say, look, I don't want to browse, just unpack it right where it is. That's nice. I should bring up a tip on this one though, because I've seen it all through beta. If you're in the habit of double clicking a CTF file in the folder, like from Windows, when you do that, you're using Windows Association. And at least on my PC, where I have several versions installed, this option wasn't showing up. You probably know why, because Windows Association is linked to some file. It's opening an older version of Unpack. So either you got to go in and mess with your Windows Association or not have an old version installed or use Unpack from the menus, but you should be seeing this. And then let's talk about a new function, pack to share, okay? This is pack, the same function, but we added some options to it. And the idea for doing that is this is what you should use if you're one of these good users creating all this intellectual property that you want to share with other Cimatron customers, which is great. But you don't want to give away that intellectual property, your catalogs you've worked hard on, your setup table logic, all the stuff that saves you that time and gives you an edge. So this is what you'll use. If you think about these 6 options here, let's talk about them. So breaking links to catalog files is actually mandatory. Otherwise, there's no reason to even use this. The catalog links won't be there. Anybody who unpacks this will not instantly get a big reconnect message. It just doesn't happen. We don't worry about them. You can optionally do more, like reset history on all your parts, or maybe just catalog parts, because they're yours and you don't want anyone to be able to explode them and see how you did it. Or maybe you want to break the annoying links to other parts. This happens when you use import to part, export to part. We keep those links, and sometimes files you don't expect end up in the CTF. So that's that. They're all set up table entries. Like I said, it removes that logic. And then it can even be used to remove the display mesh. There's no logic benefit there. It's there to make the CTF smaller, if that's what you want. Try it out. Let's move over to data interface. Gets a few new things, just like it always does. So one is a new checkbox in import step. It's called import graphical data. And it's not so obvious, so let's talk about it. Once in a while, a customer will come up with a file, a step file that has size, but it seems empty. It's because there's no surface solid data, no BREP data. The reason it has size is that it was storing the mesh, really just the display mesh. And we can read that, we just weren't doing it. So now we have this checkbox, which will do it. It's still not an obvious situation, so something nice happens here. If you run the file, import the file, and it ends up empty, we're just going to immediately run a check to see if the mesh data is in the file. And if it is, we'll pop up a little thing that says, well, use this option, and you'll at least get the graphics. We have to do it that way because we can't just import everything at once. It's a translation thing, but it's a clever little option. We added import Rhino files. That's a direct translator for that system. Nothing much to say about it other than it exists. Rhino doesn't do assembly, so we have that option for multi-object to assembly. And speaking of direct translators, there's the CATIA one, which is very commonly used. We've got two new things there. You see in the circle, import models in work state. You're getting a direct file. It's not step-arageous, which means that the CATIA concept of in work, which is the same as our insert mode, affects what's being seen in the CATIA model, even though the features are there in the tree. And we needed a way to control that, whether you get the end of the feature history or where the user left it. So that's what this is about, insert mode. And also there's a part number attribute in CATIA. We weren't translating it. This was just brought to our attention from some users, and now we can put that right into the Cimatron standard number. These are all good things. On the export, this is the one I want to talk about. Here's a new translator. It's called export as HTML. And this happened just kind of because we noticed Google created a free library that allows CAD data to stand alone in a web-readable HTML file. So we export our OpenGL data, which is our graphics, our display. That is the data that goes into the HTML, and in a way it becomes a viewer. But no special viewer is required because you can open it in any internet browser. The export parameters are much like an STL file because it's display. So you see we've got triangle control. You can click a box to add the edges, which is on by default. You want the edges. And there's a default background you can throw on there that says Cimatron. That's an option too. So all of that's pretty good. You see what you can do. It's just a viewer. You can zoom, pan, rotate. Nothing else so far, but we don't know where this will go. I think at the moment, it's just something cool, and if it becomes a popular thing with new features, we will keep adding them. Okay. This is a good example of a feature that needs some discussion. It's a new ability. It's considered a data interface thing, but really it's not a translator. I'm very interested to see how many people use this. It came up in a sales kind of issue, and we talked about it. From what I can see, not many other systems are really attempting to do anything like this. At least not any without a PDM system like us. And the basic idea is to let a user know if new data has appeared, DI data from somewhere else, and they want to know. I think it might be nice for any user, but it's especially nice for silo users like customers who are only NC, only electrode. We know they rely on imported data, right, to go into their Cimatron. So how it works is this. Any type of file, which is part, assembly, NC, or drafting, all of them, if it started with an import, it can look to see if some other DI file other than the one it was originally based on, has entered the folder. And if so, you get a pop-up like this. The check runs when you go to open the file. So as soon as you're opening the file, you see this. Note that there are 3 options in the window. One, you can acknowledge the alert. That's probably the most common thing to do. Say, yep, okay, thank you. And then the DI file that it noticed is considered handled. And by handled, please understand, this warning is all you get. That's all this utility is about. Data monitoring doesn't mean that we've replaced ECO, or all the work that you have to do to process a new file. It's not an update mechanism. It's an alert system. So, in this case, yep, you acknowledge it and things are okay. But maybe you don't want to do that. Maybe you don't want to deal with it at the moment. You can click the one that says remind me later. And we can do that because it's not as simple as just keeping track of when a new DI file shows up. We actually keep track of the last time that you said, yes, I acknowledge that DI file. So we can keep telling you about it if you want to put off the process of messing with that file. And then there's the last one, of course, and that's just going to turn the alert system off. Data import monitoring is a preference-based option, but it's a file-based preference. So if you click that, it's going to turn the preference off for the file. It has a preference page. Here it is. Now, just because it's a file-based preference doesn't mean you can't turn it off for the whole system. You can. If you get any questions about it, you can help users to do that and understand it. If you are going to use it, note the other choice here. Let's talk about that for a sec. So you can do one of two things. You can ask for the system to only look for DI files that are named exactly as the original file, because we know what the original file was. This was an option that the customers wanted. In my experience, I don't think that happens very much. I think when you get a new DI file, it's going to have some rev number or some change to the number, right? But like I said, customers wanted this. They probably have someone who conditions the data, sets up a naming system, so it's fine. That's the option they will use. The other option, though, if you're not worried about the exact name, will just monitor the folder for any DI file that has the same original type. So if you import a step, it's going to look out for step files. That's also nice, but it assumes you're not putting a ton of unrelated data files, DI stuff, into one big folder. And I don't think you will in a job folder, but if you do, you get a lot of false positives. So it just comes down to knowing that the source folder is important, knowing what option you want to use. And if you play by the rules, it's really a cool kind of new thing we can do. The last thing you want to know from a technical level here is that, again, it's checking for files based on DI. So if you open an NC file that was used with load model from a Cimatron file, that doesn't count. Load model is already an update type of feature. It has its own ability to update to the model. So we didn't need to do that. It would be the part based on the DI you'd open and get the warning. And it doesn't have to be file import. Last little note here, it works if you've used import to current too. So anyway, test it out. Cool feature. We are jumping over to assembly. Hopefully you're sticking with me. I'm a good half hour in here, but we've got more to go. Let's start with some projects related to Cut Manager. Cut Manager is so important. It's a vital tool. It's in every add feature we have. It's in array, copy, automatic cut, relocate, a lot of functions, right? And generally it works great. But the enhancements we've added were designed to solve some problems that were brought up to us by some of our best customers, those strategic customers who are doing the really big jobs, important stuff. And that's why I have this picture here. Came from a real customer who was concerned. Of course, they need Cut Manager. They've opened it up, but the number of parts on the list, just in this one case, and it happens a lot, was over 900 parts in one cut analysis. And most of them, almost all of them, were parts like baffles and other things that are blocked from being cut anyway. They have the attribute. Besides that, it's super slow. This took many minutes to open. And the third problem was that once you do get it open, nothing is in any logical order. So they're sorting through 900 parts. All right, all real problems, and we needed to help. So we started looking at it. We re-examined the contact analysis. There wasn't much we could do there. Cimatron is doing a great job with this, knowing what parts should be on this list in general. So we turned to filtering the list itself. And we made a preference that dictates that, hey, we're not going to show parts on the list that can't even be cut anyway, which makes total sense. But the reason it's a preference is just in case, okay? If there are users who really wanted to see every single part that the new one bumped into, because that's the way it's always been, I didn't want to alienate them. So you can turn this off in the preferences. By and large, you won't. The cut manager list looks much better like this. Another thing it does is sorts the parts in a logical order. So the topmost part will now be always the one that supplied the face or the cone that you added your component to, if it was that kind of an add. Then you're going to see the parts that are checked on by default because of the cutting rules. Then the parts, if they exist, that are just cut by one instance, which is the ones with the black square there, and then the rest. The order is not dynamic, which means as soon as you click something, you're not going to see it jump around on the list. That would not be good. It happens once the analysis is done. So if you do get out and then edit again later, yeah, it will reorder at that point. Another thing we did here is we added a box where you're going to see the name of the cutting object you're working on. Now that box there for first object, second object has always been there, and that's good, but we had to do this. We've all used attach name, and when you attach cutting object status, you're allowed to give that cutting object a name. And we noticed that all those good users, the ones making the clever little assemblies, were doing this, giving it a logical name. But it was wasted effort because they never, ever see that name again. There was no way in the system to show it to you. So no payoff for that smart work, and now there will be. So if you bothered to name cutting objects, you'll know exactly the ones you're working on. Admittedly, if it's a catalog pin from us, you're just going to see the default cutting object names, but that's fine too. No big deal. Still sticking with assembly cut and cut management, and I'm super happy to report this. You know, if you added a single part and then you edited later, we could always show you exactly how you left the cut manager. Those boxes would be as you set them. But if you added anything that wasn't a single part, like a small assembly, something that you built to save yourself effort, it never worked. Every single time you edited the add, the cut manager would show the default checkboxes and not what you set. Absolute worst case scenario, because it's those small assemblies that have the several cutting objects and interacting with lots of parts. You know, you've got the window expanded like this. It's just when you need it to show you what you had done. And because it's a lot of interaction to manage. So we fixed it. Now when you come back to edit, whether it's to change something or just to see what you had done, you will see the checkboxes reflecting the way you left it. So happy. It's really going to help in a real world setting. So also, we did make a change here to a pop-up warning. Now, everybody's seen this warning. It's the one that acts as a double check after using the cut manager. It made sense to do this now. We were in here doing some other stuff, but I didn't take this change lightly because honestly, it's a very good pop-up and how you answer it is important. So let's talk about it. The original language would say this. It would say that the system recognizes changes in the list of parts recalculate the list. Well, what list were we applying? Honestly, the cut manager has a list, but that didn't change. What we were really saying was, do you want to recalculate the status, the checkboxes? In 2 sessions today, we're talking with folks that deal with a lot of language translation. Now, I don't know what the wording was in the other versions that weren't English, but I know we could do better. So, and I think you know this, but I'll just keep going into it. So this popped up in 2 different type of situations. Half the time it pops up, it means, do you want to revert to the default cutting rules? Just in case you added another part, and always we'd say no to that. But the other half the time, it would come up after you use Cut Manager, and it would be like confirm, where you'd say yes all the time. It just wasn't really clear as to the action. That's the story behind the change. Now you see what it says. Changing the size, location, or quantity of added parts might create contact with other parts. Do you want to use the default cutting rules? Plain and simple. And I will say this, it pops up in a couple different cases. At the top, I was just telling you how happy that we are that Cut Manager works for small added subassemblies. So of course we had to add it there too. We never did before because it always defaulted to default, whether you wanted it to or not. Now we have to ask. On the other hand, we thought it was safe to remove it in a certain case. And that is this. If you use Cut Manager and then you go right to the green check mark and okay it, we're not going to show you this anymore because it's clear that you were just using Cut Manager. So of course, that's what you want. We're not going to make you confirm what you just selected. I hope this goes over okay. That's why I'm explaining it to that depth. All right, next is our project on dealing with user modified catalog parts. We had a problem to solve here. Every time we issued a catalog update, a user would perhaps not want to apply it because their copy of the part had been customized. This comes up all around the world. Some of you know this issue very well. Generally speaking, that user customization was either a color assignment or a manufacturing attribute. And usually it was on the cutting object, not the part itself. So we have discussed it for a while now. What should we do? Are we going to tag faces, create a big project, update 40,000 catalog parts? Absolutely huge. So we decided to try this idea first. What if we could just let the users update to our changed parts, but not lose their custom changes? What if we could transfer them over? It's worth a try. The process is this. Okay, you're getting the catalog update. If you're up at our catalog server, you need to choose the option to download as a zip file. I hope that's obvious, because the other option is to back up and overwrite your parts, and then the deed is done. It's too late to do any sort of comparison. So do the zip download. Users will understand that. And then run their new utility, which is called merge new catalog files. That's going to open up this. I've made it as big as possible because it's a scary dialogue, but really it's not bad. At the top, you only do 2 things. You pick the zip file you just got, and you pick the folder where the new parts are going to go. Then we run the comparison, quick analysis, and we sort them out into 2 bunches. If there's new parts in there, we don't need to do anything. You're just going to get the new part. But if we find that the same name exists, then we run an extra bit of analysis on them. And it's actually 2 bits of analysis. And that's what these checkbox areas are for, okay? Depending on what we find with analysis, you're going to see an option for each part, because maybe not every part has something different than our catalog. Right? So if they're the same, that's fine. Or if you want to, you can move your values over from the local table. In other words, your table. If you've changed any numbers or added rows or removed rows, you can still keep that, put it in our catalog. And then there's the thing about the attribute status. So again, depending on what we find, we can let you choose to bring over your attributes and apply them into the new catalog. There's not a checkbox for geometry. No, we do not transfer change geometry from customer part into ours. It is too complex. Things wouldn't line up. It's not a worry, because I think once those users go that far, they've changed the geometry of a catalog, they're devoted to it. They're not going to even bother with updating from us. After you run this, you get a log file. It's going to tell you what you did. All in all, I think it's going to do a great job. It's going to solve a lot of the problems it was designed for. It does need real world testing, so that's going to happen soon. Hope you like that one. I like this one. So now we're moving over to other things in assembly, like that are shared with mold and die. These are the applicative add dialogues. We have a lot of them. Add mold component, add cooling, right? They're actually all about the same. They just have different starting points for the subcategory. And you've always been able to use these and just browse to the component you want to place. And that's something you're still going to do. But now by type is just one tab of the dialog. There are two other tabs here, favorites and search. When the system is first installed, there's not going to be any favorites. Every user has to define their own. They do that with a right click, just like you're seeing there, add to favorites. Couldn't be simpler. The list is kept in a system XML file, which means that you can share it PC to PC, like all kinds of other data files in Cimatron. Just like any other type of a tab, the favorites tab is organized by the catalog you've chosen. You can, however, switch to a special selection on that tab, which is called all catalogs, which gives you a much bigger list of all your favorites. You can remove a favorite too. That's a right-click option. And now you see this movie I'm running is talking about search. That's the third tab. It's a keyword search. And again, you can set a single catalog or choose all catalogs. That was actually a quick search, but it depends. If you've got every catalog installed, 40,000 Cimatron parts, a search can take a minute. I think that's perfectly reasonable. It's going to find them for you. Good stuff. As we looked through all the mold design requests, I found a bunch of them about cooling, and we decided to just tackle them all. This closes a ton of enhancement requests in the system. Little small necessary needs from strategic customers too. What I'm talking about affects both the cooling object function and also the add cooling item with channel. So I'm kind of talking about them at the same time. Both of them make cooling lines with drilled ends, and that's where the changes are. There was a few problems. Some of them were just bugs with remembering last use values. And that's a fix we did, but we did more than that. Especially in the cooling object function, the one on the top, we actually moved the parameters of the drill out from the optional step into the main step. The optional step still exists, but now you just use it to do the one specific individual change. And that's really why it was there in the first place. So that we covered all the needs 100%, we also did a preference addition. So parameters like the ones we're talking about, drill type, drill angle, they're all in the preference for both functions. And then one other thing, just to mention it from the what's new, is that you'll be able to use same component when you're doing cooling item with channel in a few more places, like the option for no channel. If there's no channel, why can't you use same component? You can. Okay, this is the only slide I have with red on it. We've been working on this very needed mold design function called vent channel creation. And we knew it would be a big project, but we heard the strategic customer saying, doesn't matter, get started on it, give us whatever you got. So we did. We started it in phases. And phase 1 for this version was really just the first type of vent, the perimeter one, the kind of vent that follows around the part contour at a specific offset distance. And the function got a lot of work. It does exist, but it is having trouble with geometry creation. You can imagine, not every part is simple. It goes up and down all over Cimatron real parts. So we know it's going to be delayed, but I'm talking about it now because you will get it soon. In action, it's kind of like runner function. So you enter only a couple parameters, offset, and then there's a dialog where you pick the shape. And we use three shapes from the customer recommendations: the round, the rectangle, and a V. A minimum of parameters. It's really the depth that's important for these air channels. They don't have to be super precise. And yeah, it's got an option to adjust the ends of the offset curve just kind of dynamically. I really like that. Anyway, once we get it working, we will work on phase 2 of the function. And then you'll have the perpendicular, the spoke type vents, as well as the option to just do both kinds at once. Please understand that quality matters. So soon we will have this. Here's another new function, all new function. It's called extend and cap. And I am pretty excited about this one because I think it's relevant to mold and die, but I just think it's also unique to Cimatron. So it's a surfacing design tool. And yeah, both mold and die have this kind of similar need. So we were happy to work on it. And it's intended for a situation like I have circled here. Okay. I know all parts are different, but all of them have little features and areas where parting line is going to vary. And a lot of times with the little stuff, you don't want to extend the shape all the way to the edge of the tool. You just want to bring it out a bit and then minimize it down to the larger main parting or binder surface that's around it. So we thought maybe we could automate this, which is what you're seeing in the orange. And it's a cool function. It has some options. First, of course, we're extending from the edges, tangent or in a direction. That's one option. And then we're capping off the shape. How do you want to do that? By an angled plane or round the end? That's another option. We've all had to do this manually. It takes a surprising amount of work to make all the edges and planes and trims. So if we can do this automatically, it's going to be great. What would make it even better is if we could trim to faces underneath. So that's an optional step in here. If base faces exist like these, you can go to the optional step and ask it to trim to them, which isn't easy. Base faces may be 3D, they're falling away, they're rising. It's a challenge. I know of at least one trim case we've identified, which is definitely not going to make the official release, but we will work on it for service pack. This is another one we've been working really hard on. It's exciting. We want it to go well. So look out for that. Time-wise, I'm doing fine. I just want to keep that in mind. I've got a few more slides here, and then we'll turn it back to Guy. But we moved into die design. And I don't think it's any surprise that the big ticket item in die design is die quote. Of course, you've heard of it. It's a whole new package. It has special functionality. And probably you've seen it by now. So I am not going to go over it here. We don't have time for that. I only mention it because, like it or not, die quote required most of the time we had for die related features. Okay. And I'm sure it's going to be worth it, but it just means I don't have much else to show you. I do have this, a few things for Springback. And Springback is a great Cimatron tool, very useful in the real world. Often it's being driven by a huge amount of point data. And if you've used it for that, you know that oftentimes we're scaling points. That's an opportunity to customize the results. So you get in there, you group some points, you apply different scaling, you're trying things, and there's some work involved there. And up until now, it was really hard to reference those groups of scaled points. They're just random in the list. There was no real sorting, so that's good. Now we can sort it. Up, down, or not. Remember, there's thousands and thousands of points, so that's kind of nice. And then there's this extra click. It opens a selection window for your scaled points. It allows for point color control, even on the screen. You can search for a specific scale factor, and it helps select them. So a lot of nice stuff in that box. Very welcome in Springback. Moving on to electrode. I'm really happy that we worked on this. We needed to step up. I don't want to say that we've done anything too earth-shattering in electrode, but a lot of nice features, really. So to begin with, adding a holder can now be performed with a cut to the electrode blank. It's okay if you're asking why. We didn't do it before. Many holders are made with a pocket or a slot. And the point of that is that the rough cut blank gets clamped into that feature. And we just never acknowledged it before now. We just stuck the holder on the back of the blank and let the user deal with it. Maybe they just left it looking funny like that. The right thing to do was to go into the holders, the ones that needed it, give them a cutting object. And we did that. They're already on the catalog server. And then allow that placement of the holder to be done with cut. So to make sure that worked, we've also messed with a few of the UCSs, put those at the right spot. So anyway, try the holders, make sure they work good. The result is certainly better. Looks like it does on the shop floor. And there's a second option here. I shouldn't forget to mention, when you add the holder, you can set the rotation angle to be automatic to the blank. We had already done that last version for electrode UCS, automatic to blank. So it goes right along with that. Now the holder will do it too. It's the default, just as it should be. And both of those options are parameters, which means you can save them in your electrode templates. Very good stuff. The only other thing I have time to talk about in electrode are a pair of safety checks. The important one for me is the one about electrode UCS. It is a preference-driven check. We've got it on by default. So if you're getting a question, what is this pop-up? That's because of this. Now I've circled them. Note that the wording, it says prevent output. That's what it does. So if you've got this on, it will block your post or it will block your drawing creation if the electrode UCS is missing from whatever you're trying to send. And that's good. It's quite important actually, because as we know, the electrode UCS sets the burn endpoint numbers. And if you don't have one, the numbers are going to come from a different spot and be potentially very wrong, which leads to scrap parts. And anyway, this is a valuable check that users ask for. What you actually see, the details of it, it's a pop-up. So it's just going to say, hey, these electrodes are missing your electrode UCS. It'll list them. It'll even activate the one that's got the problem or the one on the top of the list so that you can fix it. And the check for NCUCS is very much the same. And we know not everybody uses NCUCS, so maybe it's not quite as important. But it runs if you export your electrode to NC, either through that NC function or even the button in the post can be customized to send to NC. It checks there too. And you're going to see which ones have the mistake, so you can go back and fix the problem. I will say that it doesn't work the opposite way for NC. When you're in NC document and use load model, we're not checking then. If we get feedback that that's an important thing, we'll deal with that. Takes me into drafting. You know, it's not a gigantic bunch of stuff, but we definitely did what was required in drafting. The first feature, though, I'm still talking about electrode drawings. And yeah, it's a bug fix, because generally the dimensions that Symmetron makes in drafting are very smart. Ordinate dimensions, if they're too close to each other, just move aside, they jog. But the electrode drawings didn't do that. So you'd often get something like you see on the left there, where the dimensions were stepping on each other. We were able to go in, make electrode-based ordinates a group so that they could recognize an auto space, just like they should. And we did another thing for dimensioning, which was develop the intelligence in dimensions to recognize holes in cylinders in side views. And now they get the automatic diameter symbol. This was pressure from competition. Most drafting packages do this. Good logic, working nice now. So it understands in side view the difference between what's a hole and what's not a hole. Maybe they're just parallel lines. So very nice, automatic. It works on hidden lines. It works in section views. It works anywhere you expect it to work. Drafting templates. This was one of the bigger projects too for drafting, because drafting templates are really nice. They can do a lot, but honestly, not everybody uses them. And there was a few reasons for that. So we just took up all the enhancements and did them. One thing we did was to immediately show when you open the template dialog what sort of template you picked. The reason was when you pick a template by name, if the name isn't descriptive, you don't know, right? So now you can see right away. Secondly, we added a folder browser to place the drawing in a specific folder, or the drawings that you're making in a specific folder. Before this, what we did, just reminding you, probably you know, that we put the drawing in whatever folder the part was in. That still works if you want to. We didn't break it. It's just that we know moving drawings later is a big reconnect hassle. So if you wanted to put them in a folder, now you can. And really, it's this third thing, the highlight I'm adding to the screen, that I think is what helps templates reach their potential. The problem with them was you always had to have a very specific template for every situation. If you wanted 2 sheets with 4 views each, you needed a 2-sheet 4-view template. And nobody was going to save 8,000 templates just for every situation. So we can help. Now there's a right click to just add a similar sheet. So really, you just need 1 sheet. And if the situation calls for more, just click and add them on the fly. No more having so many different drafting templates around. And if you have too many sheets or views, you can just leave them empty. Before, it wouldn't let you create the drawing. Now it does. So it's an easy way to just drop things that you don't necessarily need. All in all, a bunch of good stuff that's going to help templates get used. And this is my last slide, guys. Thanks for bearing with me here. These are a couple functions that started out in drafting, but really they're for everybody. Just as useful in modeling, because we make text everywhere. We now store recently used fonts. We put them right at the top of the font list, just like Windows does. It's going to be obvious. Everybody's going to like it. No more searching through the huge list for the one you want. On the technical side, I will tell you that these recently used ones are stored in a system file. It's easy to get at, but and yeah, we store a different one for modeling and drafting, just in case you're using different kind of fonts, you know, between engraving and what you like on your drawings. And along with that, we decided to expose in plain sight the drop-down list for text sizes. So it's a preference page. It's a system preference. It's units based. You get the entries for metric or for inch. No one could ever figure out how to get at the sizes. You seem stuck with the one Symmetron wanted, which were never what you wanted. So now it's available. And yeah, no more typing text sizes, I hope. Okay, that's my rundown through everything in 2026. It's a bunch. I'm going to stop sharing and give it back to Guy.
Thank you, Dan. Along the way, there were some comments on the chat.
Good.
Starting from Andy. Could we have the option to delay the calculation of the mass for each object, like run and calculate at the end of the day or something like that?
That option does not exist today. It has been talked about. We should be able to do something cool. I don't know, maybe even send them to Superbox, but everything requires a project. Yeah. It's a good idea, and I will. We've been doing that stuff in phases, so the next phase is something with performance, Andrew.
Yep. Okay, Danny asks, Sketcher self-intersection warning also look for overlapping and duplicate geometry?
I want to answer this correctly. What you're asking is, what is the definition of a self-intersection? And I'm not sure. I might have to ask the dev. I don't think it is there for duplicates, but it should cover any case where you get into a feature and that feature complains about your sketch. That's what we're trying to stop, is leaving a sketch and having to get mad and go back to it to fix it because you didn't know it had a problem. Probably we need an example, Danny. We'll just keep trying that.
Luca asks, does the reference manager rerouted work with assembly feature or only with part features?
Okay. I can answer this. So we use the reroute symbol in a different way in assemblies. You'll even see that little broken symbol like when a part's missing. So there's two ways to answer this. The search certainly works at both levels. It'll find anything. Generally, though, what we think of as a broken feature is only part level. Now, I know in assemblies, you can make some features. You can make a sketch. You can make a couple things, but you really can't make extrudes and rounds and all those in assemblies. So I kind of forget. I'm pretty sure reference manager, which is exactly what you're asking, Luca, is only part, that portion of this new feature, because that's where all the reroutes are really at. But the search and the marks are at the assembly level.
Okay, Danny again, about data interface import monitoring. What happens if the user's current system process includes a revision in the file name? Part rev 1 step to part rev 2 steps. Does the rev need to be stripped from its name?
Read the rest. I see it there.
Yeah, I did not.
Hey, that's why there's a preference, and there's only so much we can do without a PDM system, and we don't want a PDM system. So, yeah, it will tell you that Rev 2 showed up. I think that's really important, but you have to be using the option to say files of type. And that's why picking the folder is important. These are going to be in your job folder. Let me put it this way. If you were the kind of shop that just has one folder for every IGES file you ever got, you don't want to use this. It's never going to be able to tell you anything. But between the folder and the name, there's two choices there. Let's get it out there and see what we need to do more. Of course, we'll answer.
Okay, Jay says vent channel is needed in die for wiring and hose channels. Can we add to the die design menu and rename as necessary?
Sure.
Yeah.
Yeah. Well, wiring and hose channels is a whole nother project. And yes, it's very similar in nature. So of course, we have just as much pressure to do that as anything. It is on the list. We've got to get vent channels working. And if we solve those geometry problems, then it just makes those other projects that much easier. So yes.
And from the other side of the Atlantic, even, and this is about the electrode, and it says the still missing dimensions for the holder, mandatory.
Yes, sir. I have a wonderful specification writ for that with color pictures and everything. It just didn't make it. It will be the first thing I have done in electrode for 2027. And that's our unfortunate reality. We got a lot though. Let's not get down about that.
Yeah. Okay. Then he commented again on the calculations as remote Superbox or remote worker. And finally, Rich, I'll jump back to you, but Danny also says duplicate does not seem to warn Sketcher. That was the comment.
Okay.
And Rich asks, does the last used text carry over from session to session and from day to day?
Yeah, Yeah. Remember, it's not like what you type, it's just the font. And it goes into a little system file. It's day to day. It's forever, actually. But it's not, I think we limited it to like 6. So if you're jumping around to lots of fonts, they will fall off the list.
Okay,
Okay.
that's it. So thank you, Dan.
Thank you guys for bearing with me.
It was fun.
Yeah. Lots of good stuff. Lots of good
And
stuff.
even more, right, Uri?
Yeah, even more. Yeah.
Okay, Yuri, stage is yours.
Yep. Okay, guys, we are talking about the integration with Excel. This is a little bit technical session. So you should be familiar with Excel a little bit at least to understand what's going on here, but it is something important. The input from the users or the request from the users, they ask to do something when it comes to complex assemblies, maybe like, a die set or something. The requests come from all directions, can be a simpler UI because setup is just a flat list almost, just folders and calculation, missing calculation types and so on. There is also issue with setup limitations that we want to overcome. And if you're not dealing with these two issues, just simply continue using the setup. I mean, if you just want to type in numbers, don't mess with the integration with Excel, okay? It should really, worth the effort you're going to invest, so it should be complicated or overcoming some limitation. It is included in Cimatron CAD, no additional module, no additional license. Targeted to expert Excel users, this I told you before. About macros, we do not support the .xlsm that contains macros. If you want to run macro, you have to run it from external Excel file. It is available in 2026. The dialogues in the official might be a little bit different than what you see in the beta because you need to try to make it better. This is one of the input we got from the beta customers. I showed this movie yesterday, but it's only 1 minute, so we can look at it again just to understand what we are doing here. This is a setup. There were additional like 20 parameters hidden here, which we don't use because they are locked. They will be populated by Excel. The user is going to change the Z height. Now it's 400. This blue circle will jump immediately down to show where do you want this fixture eventually to get. And then we are exporting the data, the new Z height to Excel. Look at the Excel reading, select the appropriate catalog size of this fixture and bring it back to Cimatron with different configuration, of course. Okay, so let's see the movie. So as I told you, the user is using this configuration 400. It's a big fixture. He's choosing the smallest one, the 30 millimeters height. And as you will see in a second, the circle jumps down, very small fixture, exporting to Excel. In the Excel, the requested value appear, 30. You select from a nice list of catalog parts. You can see here before that this is the current fixture, and you see all the numbers appear here in the legend very clearly. The height, the dimension of the base, about the screws, and so on. Now the user select from a drop-down list the catalog he wants to use. It can be done automatically, but here we select from a nice list. Automatically the values change, showing him what is the impact of his new selection. And then go reading the data back to Cimatron, and voila, the new fixture is created. Of course, it's different configuration, much smaller, but also less screws. What you don't see here, but if you open out the mounting screw diameter, you have very limited amount of diameters because the fixture is small, so the Excel can control the list of possible or legal screw diameters out of the huge list of the catalog. Okay, so this is it. It's a new configuration, and this is a very small example of how it can be used. Okay, some rules I want to tell you if you want to do this kind of stuff or play with it or test it. There are some kind of rules behind it that you should must follow. First of all, the Excel file must be located in the current folder. Okay, there is a possibility to select from different folder, but the system will copy it to the current folder. You can have one file for exporting and one file for reading. Mainly important if you're dealing with macros, so you process one file and you output it to the other file. Any file name is okay. As I said before, only the standard format of XLSX do not support the old format of XLS and no macro of XLSM. Only this format. The file status, it must be closed, save and close. If the Excel remain open with the file in the Excel, both export and the reading will fail. You get a warning, of course. When you are reading from the Excel, important notification, we just update existing parameters. Update a lot of stuff. We can update lists, as I said before, even names, values, whatever, even formula if you are really brave. We cannot delete an existing parameter and we cannot add a new parameter. Okay, this is what the Excel integration currently does. In the Excel, there are predefined or names of the worksheets. Export is exporting always to the sheet that starts with the 10. After that, you can have any strings of characters you want. And if there are multiple sheets, start with 10, the first one. Reading is always will be from a spreadsheet start with 20. If you have several, the first one. So immediately you see that you write to a one sheet and you read from another sheet. It means that if you export to Excel and immediately try to read it, nothing will be read because you are just export to this one and the second one is still empty. This is a little bit surprising behavior. Usually in Simultron, if you export template, you can immediately use it. In Excel, at least for now, you have to do some processing. Images, it's a minor issue to me, but you have to solve it. Again, it's kept in each image kept in its own sheet. It has some kind of a name ruling how to do it. The exported sheets go to 11 something and the imported sheets go to 21 something. Those funny numbers are the IDs of the setup parameter. You don't see that, but this is how setup works with IDs, not with names. So in a group, that's the group ID. And this is the group ID and the parameter ID. So maybe you wonder, how do you get these crazy numbers? Very easy. You just export to Excel and you get all the numbers. You can use them later. Parameter attributes. Each parameter has this list of attributes. It's a long list of attributes. Some of them make sense to you, like the parameter name. You will recognize it from the setup. The group name, you also recognize it. The value, the unit, description, this is all easy. Now you start getting the attributes related to formulas and to rounding and to catalogs. A lot of stuff. The last item is just a list of values. Important, for example, if you are using just selection from list, so the list will be here. Okay. So this is the items. If you want, oops, sorry, I have to go out from the presentation mode so I can open the included Excel. This is how the file looks like. This is the very long list of attributes. Okay, these are the sheets. As I told you, starting with 10, and after that, I just put something in English so it makes sense to you. It can be in Chinese, in German, whatever. Just start with 10, and this one should start with 20. Okay? A parameter format, how you express the format of each parameters. You can have this in this Excel, included in the presentation, and it tells you how a format is defined. For example, in a group, you see the group name. It can be selected, forget it for a second, the group ID. And if it has picture, you have it here, and so on about each parameter. And some parameters get complicated because they have all kind of lists. Can be list, rounding list of catalogs, and so on. Again, don't panic. If you want to understand how the format of a parameter looks like, you simply make it in the setup, export it, you get all the information. I have here Cimatron file with all the kind of parameters supported, so you can use it as a reference. And okay, so we have this one, and this is the Excel created from that file. It's quite frightening, so I'm not going to open it. It contains many parameters. Okay, so this is what you have in this slide. You can use it. By the way, the master Excel file is kept here in the source data. So if you want, you can change the colors or even translate it, because we don't use the names. We just use the column sequential order. Workflow, just an example. Of course, you have to prepare a Cimatron file with a setup. Better start with few parameters and don't start with your 400 parameter setup. Export. The best way is to select the option of use default Excel file. We just use the system Excel file. It will be copied to the local folder. There is a file like this, will be overwritten. Later, you select the third option, select Excel in the current folder, and you just work from the current folder. And when you export, at least in the beginning, it's recommended to checkbox this one, open the Excel file. So you export and immediately it appears on the screen. It's very convenient. Work in the Excel. Over here, it's Excel, but what is important is that usually you copy the relevant parameters from the exported sheet to the sheet that you want to use for import. And maybe I can show you here an example. Yeah, maybe here. Yep. If we look at this one, so here is Excel, never mind what it does. But if you look at it, you will see that the exported, this contains many parameters. But eventually, I want to send back to Cimatron only one parameter. So the 20 sheet contains only one parameter. That's all. Okay, how did I get it? I copy it from here and paste it here. Now I can modify it and so on. Okay. You can change values. You can change even list, as I told you before. In this example here, what you see, it's a catalog, and this is the list of the catalog. This one. These are the value, the drop-down list that the user will open, not the full list of parameters of that screw in this case. Okay. You can again change parameter name, and this is something you want to do. You can look at how formulas look like. I suggest don't mess with that. Don't start with changing formulas, although it's possible. You must save the Excel file and you must close the Excel. Okay. And then you read it back into Cimatron. And if it's successfully, it's great. If not, you will get a log file. It will be open. And the log file is relatively simple. It just tell you which line was read successfully. And then you see that line 13, it means 13 here, yeah? This 20 worksheet. has a problem. Hopefully the description is good enough to understand what the problem is. So this is the general workflow. You prepare the setup, you export, you modify, you can use macros for that from external file, and eventually you read it back. Handle images, don't want to go into detail. You should again copy the worksheets. We have examples here of before and after. I don't want to go into it right now, but you have the presentation and you can look at it if you want. How you access the data that you just exported? That's a good question. For example, in this Excel, all I wanted from this sheet is actually this number, 4. This is the diameter that the user choose. So how do I access this 4? Okay, so one way is to say the sheet name and then N52. Yeah, N52. So I know that I will access it. The other way is to give this cell a name and then access the name. And what I prefer usually is defining a table from this portion of the big sheet and just access it by the ID, because the ID is the only thing of a parameter that never changes. The user may change this one, okay, or maybe is going to add some parameters before or after, so the location of the cell will change. So the ID is the only thing that remains perfect. Okay, so again, I would say use this one, the VLOOKUP. Cell name is risky because every time you export, you overwrite it, so that makes sense. Populate the data, Populate the data should be the setup should read by cell name. I can show you here. So if I'm going to my export, how did I populate this list? I have a cell called length list, okay, not a surprising name. And here, this is the cell, okay. The cell name is length list, so now it's readable, I can do it, very easy to manage, okay. This is how I get the value of the 4, it's a VLOOKUP function, again. For those of you who are swimming easily in Excel, it all makes sense. Okay, how to deal with catalogs? This is tricky because Excel doesn't know anything about catalogs of Cimatron, of course. In the setup itself, it's okay. In the setup, wow. Show me back. Okay, never mind. In the setup, you can say, okay, I'm getting these values from catalog, from the diameter or from the length or from whatever you want. But the Excel doesn't know it. So what do? We create a sheet. We copy from the catalog as we see it in the Cimatron Explorer. The header list, we copy the entire data and we get something like this. You see cap screw Z31, and this is exactly what we have in the catalog of this parameter. So I just copy it manually. Probably you can do it with macro if you want, or in the future maybe if it's important we do it. I've added this column later, but if you want to deal with catalog, this is the rule how to do that. Okay, so this was very, very short. I'm going back to the summary. Just remember that it's okay to play with it, but don't be surprised that if you want to, change a value from 10 to 12, the integration with Excel is an overkill solution. Okay, and as it looks to me, we might need to do some kind of a dedicated session to those that are really interested in going deep into it. And if you have a customer that's really eager to use it, we will be happy to work with him and guide him, and if it's okay with you and with him directly. Okay, so this is all for now. Integration with Excel. Guy, back to you.
Okay, everybody ready? Everybody's expert on Excel by now? Hope so. And Oz, I think you can start.
Okay, very good. Thank you, Guy. All right, guys. So sorry I wasn't here yesterday. Great to see some familiar faces. All right, so I assume that everyone that is here was on the meeting yesterday, so I'm continuing from that point, just elaborating on some of the things we talked about. This is going to be pretty short. So we will be talking a little bit more about CAD AI and the Copilot, and then about the API. I'm skipping what I talked about in documentation, so the new online help, the what's new marking, and the large spin boxes and integration with Space Mouse. All right, so let's start with CAD AI. I wanted to show you the feedback tool that we have there. So let me jump to Cimatron. So yesterday I showed a movie of the feature detection itself. And we have another tool here called AI feedback. So after we did the feature detection, we go into AI feedback. It's very similar. But here what we can do is we can change. Oh, you know what? I forgot to show you something. Sorry, I'm going back to the feature detection. I just wanted to show you one other thing. If you click a face here, you can click face assignment data and it will tell you the confidence level for that face, right? So basically, if I will switch the confidence level to 100 here, all right, you can see that some faces become unselected because their confidence level was lower than 100. So this is just an FYI. Sometimes, not in this case, but if there is some ambiguity, you can select a face and see two results here. Let's say through hole 64% and hole with drill bottom 23%. Right, so you could have that. All right, so after the detection is done, you can give us feedback. And by feedback, I mean you can say we've made a mistake. So let's take the example we talked about. So this was defined as a through hole, which is true, of course. But let's say, no, there was some mistake, and I want to tell the system that this is a hole with a flat bottom, right? So I do that, okay? And I want to tell it that this face is, and this face maybe are close pocket with round bottom. Never mind, all right? These are my corrections to the system. And then I can see the combined assignment of the automatic assignment and my assignment. Then I can see the original assignment, so what we call the AI assignment, what the AI thought of each face, okay? And we can look only at the faces that I have changed. So these three faces, I gave them a different assignment. And then look at only these three faces, but see what the AI thought about them, right? So this is the feature detection assignment, and this is my assignment. And finally, we have the faces that are not changed. So in case I changed a lot, I can see only what is not changed. Now, unfortunately, you cannot train the system on premise, right? You cannot tell the system, these are my changes, please put that into your database and give me a correct answer next time. So if you want to send us feedback, you need to make the changes like that, save the file, and send it over to us. And then we can analyze the feedback that we get. We'll probably need to make 1,000 more parts like this, like small iterations, so that the system can really learn the change after we understand what change is required, and then we can retrain the system with those changes. So at the moment, the feedback should be sent to us. You cannot give it feedback and have it updated on your site to your preference. Okay. Next is the Copilot. So we saw it yesterday. I just want to say the Copilot is a Sandvik wide effort. You can see it, for example, in SigmaNest, and each software is training it on its data. So we trained it, of course, on all of our help files and on all of our manuals and so on, the tutorials, so on. We will train it on more things, and in the end, we want it to be able to really be a tutor. You start working with Cimatron, it guides you on how to work, it answers your questions, and we hope it will make onboarding faster. There will also be another Copilot, could be in the same Copilot, where you can tell it what to do. So we call this the helper, and then there's the runner. So the runner, you can tell it what to do, and it will run a command for you. So you can say, make an extrude 20 millimeters long on the selected faces of a rectangle 30 by 50, and it will do it. Okay, so that's the Copilot. Finally, I want to talk about the journaling. So yesterday I showed these new buttons and how you get a marking of the commands that you can use for journaling. But actually, if you get Cimatron out of the box, you won't see these buttons. So the first thing you need to do is to open them up. So if you go here to API, you need to double-click Enable Journaling, and then it will appear like this in orange. Okay, so you can turn it off. It will say it's disabled, and you can turn it back on. So you have to turn it on. The other thing is it's not in the layout right now, right? So if you go into Cimatron, you have to, to this Cimatron, you have to customize the toolbar and put them in. Okay, I hope that in the official version it will already be there. And then when you click Start Journaling, you can see the two languages you can save it in. So one is C#. I wasn't certain about that yesterday. So you have C# and Python, which you can save the file in, and then just put in some name. You can overwrite this one. And then you will see all these points that I mentioned yesterday that tell you which commands you can use, and those will go into the code. So as I said, it will be short. So this is pretty much it for me. If there are any questions in the chat, Guy?
We have one comment, a question from Danny. CAD AI feedback file should be sent to who?
Good question.
Me, probably. Here, I take it.
To me.
Send it to me then.
No, okay, send it to Guy. Yeah, Guy will deliver it to me. Yeah, so send it to Guy.
Yeah, it's best to communicate via our system through the standard way, and we will channel everything into the relevant place, in this case, to Moz. And Luca, if I have an example for CAD AI, apart from Luxottica, okay, that rings a bell, Luca, but different from the actual color table, and I think less colors information. Is it possible to define the table in a different way, colors and names?
Okay, so yeah, the feature we are working on right now is allowing you to set different, like your own names and colors. It doesn't mean that you change the content of the table, like which items are there, but you can control their names and control their colors. So this is what we are working on enabling at the moment. Of course, in the future, we want to do more. But yes, right now, and this will be ready pretty soon, you will be able to change colors and names in the table. I know people in Italy are not crazy about our colors, so you'll have the freedom to do whatever you want there.
Okay, Moz, I just wanted to note as a technical support that CAD AI is currently supplied as a separate installation. It's not yet available on 26. So
correct. Thank you for that, Guy. But I believe that by the time we get to the release, it will be there. Hopefully, with a nice little addition that the sets will be created. Let me show you the sets for a second. So if I now go to the sets tab, you will see all the sets of everything that is created. So in 2026, these are supposed to be in folders, right? So every type will have its own folder. Like these are the through holes, right? So yeah, it should look like this. Like that.
Yes.
Okay.
Very good. Okay, thanks, Mose.
Thank you.
All right. So we finished the CAD and infra stage, and we are moving to CAM. The next presenter is Gili. Hi, Gili.
Hi, hi.
Stage is yours.
It is mine. And do you see my screen?
Yes.
Good. Okay. I'm going to present almost the same presentation as I did yesterday, but I put some movies inside so it can be easier to understand which each function does. Okay, so I'm Gili Golani, as you should have known already, and I'm not going to here to elaborate each function that we have in the motion editor because I have movies. So modifying connection. Start with that. Here we can see that the connection doesn't look nice, not identical. Each one goes to a different direction, and I want to modify them. So now I go to the motion editor, go opens the motion editor, click, and I will modify the connections. Now I have to select the connection. I can select only the approach, only the retracts, and all of them, which I do. Now I click on select all here, and all the motions that I want to modify are selected. Click OK. And in a few seconds, you could see that it is changes and improved a lot. Okay, so here I demonstrate how connection could improve. I don't have to modify each one of them. I can select in case of which one or few connections are bad, meaning the approach and retracts are bad, and I can modify them. Next question is how the system knows which connection should I do. Should I go to clearance, or what is the clearance of the height, and should I make a tangential approach or just run back to clearance and so on? So I have an option here. I hope I'm going to the next one. No, sorry, this is the correct one. Again, open the motion editor and clicking on the first button here, connection setting. And here I got a table. The table will be applicable for all next operations that I'm going to do. Okay, it will be saved with the file. I can make it temporary, but normally these are the connections that I want to do. So continue. For example, this is the up, but I want to make horizontal tangential for the approach and also for the retract. And I want to go through clearance or direct. Through clearance is normal. I can use the clearance height. In this case, it's 110 and so on. I can make all the changes I want and okay. And now for the next operation, it will work like that. I can do it also, as I said, temporary, meaning only for a specific operation, I can change the setting. But normally what you want to do is to change it for the future. Want to go to the next. Okay, delete, undo, and redo. What we have here, the options, first of all, we can delete, and also I'm going to demonstrate that we have undo and redo, which we didn't have. So here I'm also in the motion editor. I want to delete. I have an option here. It was here to by brush, by polygon and so on. Here I just selected few motions, click OK, and it was reconnected. Delete and reconnected immediately. I can undo. When I undo, it undo the connection and then undo the delete. And then I can have a redo, go back and redo, and it goes like normal undo and redo normally does. I'm going to demonstrate now trim by contour, then undo, then exit the motion editor with open gaps, an option that we didn't have in previous versions. I trim by contour. Select a contour. Click OK. Now it is trimmed and connected. Maybe the connection is not what I like, but okay. And what I was trying to do, let's go here. Now I have open connections. As we know, open connection is not legal toolpath, because if this connection between that point and that point is open, meaning that the cutter cannot disappear at one point and appear again in a different point. It should go somehow between them, okay? And this point is not defined. But I can say, okay, I want to leave the motion editor at this status, and because I don't have time to continue to close the gaps or whatever, I want to leave it here and continue working tomorrow when I have time for that. I exit. Now I get a message that they have open gaps, but I leave the motion editor. It has some red M sign here, meaning it is not executable. I mean, you cannot post it because the post cannot deal with jumpings like that, but you can leave it. And then I did now undo and so on. Now I exit, and now everything is closed. Why? Because I did undo for the delete. A new option, or actually not really new, is the project on surface. In this case, we have here in the middle some, not gaps, but motion because of the drills that we have here. And actually, I don't want it. I want to be like flat. So what I'm going to do is project, and in the project I will project on the surfaces, but also in an additional surface, a cap surface that I've created previously. And now I select it, this surface, click OK. It projects everything, and now you can see that it is projected on the surface that I have created, like a cap on the drill. Okay, next, enable opening multi-NC document. That was not possible in the past, and here you can see that we have 1, 2, 3, 4 NC files and one drafting or anything, and one just part file. In this case, maybe electrode, I'm not sure. So I demo it here on a different file, doesn't matter. Under window, there are 3 open files. I can switch to a different file. This is an electrode. So we can switch back. Another open NC file, and this limitation was a problem for users when they have to work on few files. They had to open multi-NC sessions. Each session take a lot of memory, so the performance was bad. Copy-paste procedure between different TP files, like a TP type, like 3-axis, 4-axis, 5-axis. I don't have a movie for that. You just have to believe me that it works. Next one is copy procedure between NC files. So I can use the normal copy procedure, open a different file, maybe in the same session or in a different session, and paste the procedure in this file. So here I have 2 NC files. The first one with the hole. The second one is this with this slot. Going to the second one, select the rough procedure, copy procedure, copy. Now I will go back to the first file with the hole, paste. The rough procedure was created. I can now execute and get toolpath. Something to notice, like in template, the selection of surfaces and contours must be by criteria. If I select it manually, what Simulton gets is the ID of the surface that I want to select. But of course, in a different file, the ID would be different. So in this case, you must select surfaces by criteria to work, exactly as in template. And in the background, it is implemented as creating a template in a temporary place, and then import the template to the other file. The user could done it before in the past, but of course this is easier and more intuitive. Stuck. 1 second. Estimated machining time displayed here. I showed this slide yesterday. I just want to show how it works. So a different file, doesn't matter. And going to column chooser, select a new column name called machining time, add it here to the end. Okay, and now I have this column display showing for each procedure how much is the estimated time and also the total machining time in the toolpath. If I had an NC setup, I would have also the total of all TP folders displayed in the setup. Okay, and those projects I showed it yesterday. Support tool by name, allow more than 100 toolpaths, facing procedure control strategy, and allowing to multi-edit the 2D orbit parameter in the multi-edit. And that's it. Back to you, guys.
Thank you, Gilly. There are some comments in the chat. So
Yes.
first, Luca asks if is there a reconnection made in automatic safe mode with the part?
Normally, yes. There is an option to make it not gauge check, but I would not suggest users to do it. It is automatically gauge check. What happens if it is gouges, then it remain open connection, open gap, meaning defining this is not a procedure, normal procedure. Normal in finished procedure, we start with some radius of the approach. If it doesn't work, we change it to a different radius, we change the different plan on which we can do it. This is not done here because we do not implement the entire procedure inside the motion editor. So the user define exactly the radius and the type of the approach and retract he wants to do. We do it. If we fail, we make a message and we keep this connection open, and the user have to manually reconnect it in a different way.
Okay, and Danny asks, I think you expect this question, will it work with 5X Pro, the motion editor, of course?
For now, the motion editor works only on 3-axis procedures, okay? Meaning it will not work on 5X Pro. It was planned to do it in the version. We didn't have the time to do it, and I very much hope that it will be done for the next version. It is not so easy because in 5-axis we have to reconnect while changing the direction of the machine. And this is not so easy, but it is planned to be in the next version, 2027.
Okay, and a related question, will we keep the old machine editor alongside this one?
No, because we consider this motion editor as an improvement on the previous one.
But the problem
Everything
is
that-
the previous one works on 5X Pro. So none of our users that use 5X Pro will load 2026. They'll wait until 2027.
5X Pro is working as 3 axes, it should work now. If it doesn't work, we will check it and fix it. Okay, but if the toolpaths have different tool direction, it didn't work in the past, and it will not work for now. It is not regression. Again, if you have 5X Pro with identical direction of the axis, it should work now. If it doesn't, it's a bug, which will be fixed.
The old one would allow me to delete unwanted moves at the end of a procedure regardless, and then I would have the option to just pull it straight out along the tool axis in a 5X Pro.
Gilly? I think Gilly is frozen.
Yeah, looks
Frozen.
like. Okay, so I guess we'll have to look at that. Gilly seems frozen. Okay, there was an additional question about from Luca on the multiple NC sessions. If we have open multi-NC sessions and symmetron crashes, do we recover all open file? Well, we should, Luca, and if it doesn't happen, then we'll have to fix it, of course. It should manage the working sessions properly. Okay, I see Ilan added some comments on the AI. Ilan, would you like to comment, please? Because you wrote quite a bit.
Yeah, sure. I can just comment in words.
Yep.
It want to take up time. So there was a question here, which is a valid question about the quality of the CAD AI, and compared to the Pocket Manager, which has been around for many years and it is mature. So it's a conceptual issue here. Okay, so rule-based feature recognition or analytic-based feature recognition has been around, in all applications for years, right? 20, 30, 40 years. It's doing what it can do. Probably will not do more than it does today, because that's a bit of math, right? Geometry. So this is a different approach, the AI-based feature recognition or detection, call it whatever. And it's only at the very beginning. It's really, I would not even call this alpha, what it can do today. It's only what we have trained it to do, a very limited set of examples, the features that you see, and there can be files with the same features that are not recognized. Okay, we would really like to get these files, try to analyze them. Sometimes it's bugs in the way that this system works, and it's very difficult to debug these AI systems, but it can be done, and we are doing it. Sometimes it's just different examples. It might look, there is a slight round there that is not considered in the synthetic files that we use for the examples, or a chamfer or whatever. We just need to expand the files that we are tested and train it for. We are talking about around 100,000 files so far. So eventually it will be tailored to work on the features that it trained on. Okay, so it's limited today. And to make it short, we need to see the examples to expand it, and we need to fix the bugs. So please send in the files and be patient, because this is only evolving technology and it's not mature as the existing Pocket Manager, but I trust it will be much better eventually, and eventually is not very far. So we need to start from somewhere.
And Danny, it will be great if you can send us, the files with the marking, with the AI feedback, but you don't have to. Like, if you want to provide the feedback in any other way, that's perfectly fine. We just need to know your thoughts about what it does well and what it doesn't do well.
I think even the
examples of things that doesn't work are exactly what we're looking for.
I think if you look at the plate, even that you show in your demonstration video, it doesn't do a great job on coloring everything on that plate. There are chamfers that have odd colors that they should all be the same colors.
I suggest you take it, Maoz, to an offline session with Danny.
Yeah.
Okay.
One second. There was a
Sure.
power failure here at home. So, and then it was only 1 minute, but then it took another 3 minutes for the modem to start working again. So, one comment. We didn't want to have any regression in the new motion editor.
Motion.
Okay, so if there is, we will fix it. Okay, meaning if you could delete the leading motions, the first or the last motions, and you couldn't do it now, then we should fix it.
Okay. So just make sure to check and report if you feel needed.
Yeah,
if this is
will.
needed. Okay, great. Okay. Thank you, Gili.
Thank you.
Alon,
Yeah, hi.
your turn. Hi.
Hello,
How are you?
everybody. Yeah, I'm good. I waited patiently. So to continue yesterday's session, today I'll go a bit deeper into the Cimatron V2026 CAM third-party technologies. So first is the 5X auto tilt. So this is actually, it came from a use case by a customer in Germany. He put a set of parts on a lights out weekend program, and eventually, instead of cutting the 5 parts, it cut only 1 part because machining time was increased from 12 hours to 40 hours. And that was a showstopper. The reason for that was that the algorithm was not optimized. It was doing BC multi motions back and forth, and this caused a terrible machining time and poor surface quality. So what the ModuleWorks people did after I reported that to them, they found an algorithm improvement, which was a very deep development, which could now support automatic strategy selection depending on the geometry case. And then they can do 3 axis, 3 plus 2 axis, which is the change, and 5 axis. So it will look something like that, which in fact the algorithm finds a best position to do the whole strip. This applies mostly on vertical fillets like those which are very typical to mold cases, core cavities, or electrodes. And all the way it is optimized to a certain BC angle. So in fact, it's 3-axis cut. This is real optimized, and they plan even in the future to support also 4+1. Cimatron native 5X tilting supports 4+1. So if you have a smart customer, I would say if possible, on the horizontal fillets, it's better to use the Cimatron solution, and on the vertical fillets, it's better to use the 5X auto tilt. But to be honest, I do not recommend that because this is really advanced control. So you can apply 5X auto tilt in V2026 and expect much better results with faster on the machine and better surface quality. So it's 2 major improvements in V2026. You can expect calculation time to be slower than V2025, but it is still in the scope which is acceptable, and it's still most of the times faster than their own 5X tilting. So this is a major improvement, and you can play with it, test it, and recommend it to your customers. And by that, Actually, Cimatron is closing a gap compared to the competition, mostly Hypermill. Hypermill was doing a very good job on a 3+2 in prismatic parts, but here with ModuleWorks 5x Auto Tilt, we are doing 3+2 or 5x, not on prismatic parts, but on the mold parts, which are much more complex. And I think we are back to the frontier with this technology. So it's really a nice step forward. Moving on to the next item. Yeah, so sorry. So we see that V26 machining time went down to 5 hours and 36 minutes compared to 40 hours, which you can consider as a bug, but it's much even faster than the 5x on tilt, which took 12 hours. Okay, moving on. The next one is covering a real pain that we had. We got it from all of you for many years, for many versions. And the main problem with the MachineWorks machine simulator was that it was slow and very slow, and it was very painful. So what we did is interfacing ModuleWorks simulator in one version, what took us back, I would say, some 10 years ago when we switched from ModuleWorks to MachineWorks. It took us, I don't know, some 3 years to do. Now it was a one version, and we are getting a full-blown product right away. So the benefit is immediately a full-blown quality product, because this product called Maxim is available for several years with ModuleWorks, and many customers or many software are using it, including Mastercam, who did exactly the same path that we did from ModuleWorks to MachineWorks and back to ModuleWorks. Ficus is using that, and SolidCam are using that. So many software are using this machine simulator. The technology is a standalone product, as I mentioned. It has all the video style capabilities, easy to use. Of course, it has all the machine simulation and material removal, gouge and collision and axis limit detection, and it can analyze tool paths even before simulating for various behaviors of the tool paths. I can show in a glance, and a very extensive color-coded accessive material analysis, high quality, and zoom quality for certain areas. So if I run a quick demo, we can see out of Cimatron, you can load the old one called the original and the new one called ModuleWorks, whatever. Same dialogue, just flip the options and choose the machine. All is standard behavior. And this is the new ModuleWorks application. You have all the controls here. It can be user controlled. I don't go into the details. There is axis control here and toolpath control over here. So you can play with the axis. This is all standard behavior, very known to us. So looking at the toolpath, even before starting, already you have a various analysis of the toolpath, and then you can run the simulation, tool mode, part mode, machine mode. All of that is available. And now I'd like to stop here. You can see that in the progress bar, there are 2 black areas, which are called bookmarks. So based on collisions in the first run, you can, I did like 2, 3 blocks before of a collision or a suspected gouge, you place a bookmark. And then you run at a fast forward option, and it stops directly at the bookmark. And then I will let the movie go, and clicking on the step forward single block, you can zoom and analyze the suspected gouge very, very clearly and very nice. So select, go to the suspected bookmark, click forward, and then immediately and very, very clearly you see what happened in this point and then specific block, and we can see this is feed 0. Feed 0 in G-code language is fast, so this means tool that went down in a fast mode, in a cut mode. So that is the nature of this gouge or collision. And same with the second bookmark. And in this case, you can see fast motion in G0 instead in G1. So this is just an example of behavior. And now run deviation map, and you can see a clear picture and the zoom and get a high quality display. So all of that is a full-blown product and works faster, easy to use, and high quality. Let us go further and see the next one, which is a bonus. When we started discussing with ModuleWorks, they didn't have yet the GPU accelerator, but as time went by, they have developed the GPU accelerator. This is an additional option, which means it's licensed. And I'm going to show you live on my laptop, which is rather old, with a low graphic card of the NVIDIA Quattro T1000 on 2 million points. This is a ModuleWorks test platform. Inside Cimatron, it will be just a checkbox inside the machine simulation. The user selected the button or the checkbox, and it runs GPU, and it's on, off, it's toggle, very easy to operate, nothing to do. So let me run it, and this is a live execution. So first movie mode, then rewind, then go to setting and choose the GPU checkbox, check it, exit that dialog, and then go to fast forward. And when I click that, it takes 2, 3, 4, 5, 6 seconds for 2 million points. So this is very impressive, and this is on the poor graphic card I'm having. If you have customers with heavy PCs, with heavy jobs, I assume they can invest in better GPU cards, and you can expect much, much faster performance than I have been showing here. Use cases. This is first use case, about 1 million points. I showed it yesterday. So down from 10 minutes to 4 minutes with standard ModuleWorks, and to 2 minutes with the GPU. And on 6.4 million points, thanks to Danny Schellenberger, you are using that in North America for your demos. I stopped the simulation after 1 hour. It could have been running, I don't know, an hour and a half or more. So let's say down from 1 hour to 9 minutes or to 14 minutes. We are talking here of a game changer. And multiple that by a stronger GPU card. We are presenting here to the customer a leading edge technology, which MachineWorks do not have for now. They maybe are working on that, but in a click of a version, we go from a very slow solution to super fast solution, and this is a fantastic message to our customers. So 2 minutes, 8 minutes compared to 1 hour plus 2 hours. This is really a change. The transition, it's going to be a process. It's not overnight. We are talking of a machine conversion of existing machines available at the customer's site. This is super delicate. Those machines were tested and verified and paid. So customers will not be paying, existing maintenance customers should not be paying for that. And we need to take the burden. So Cimatron is checking the development of the machine conversion, or we will get it from ModuleWorks. In any case, there will be a machine conversion. You pour the machine in one side and you get the converted machines on the other side, certified and approved. If there is any failure, you should be working on that case by case with ITS, with Shuki, and the machine is a standard machine structure, and it's not it's not a brainer, but it has to be very robust, and it has to be done step by step with your span of capacity. So I would suggest offices, resellers choose primarily important customers, leading customers, and convert them step by step, as we are doing with some important customer in North America now. And eventually, after some weeks, some months, all the task will be behind you, and you could say that the conversion has been complete. So we are taking the version 2026 to do all the conversions, and that will take time. Plus, there are additional projects complementary, like machine preview, like stock preview in the process manager, like enhancing the G-code in the machine simulator, and like a material removal simulator. All those projects need to be completed within the span of V2027 in order for us to waive the MachineWorks solution. So in V2026 time life, you can expect both simulators available in parallel. This is why I showed you there is this toggle that user can choose between, or what we call original, and the ModuleWorks simulator. So it's a transition period. I think that's it on the ModuleWorks simulator. Next one is the opposite implementation. So if the ModuleWorks machine simulator was a loose interfacing, Cimatron Wire EDM is an embedded integration. Okay, complete opposite approach. And here we are saying Cimatron had done nothing. Metalcam developers, the Ficus team, have done all the work. They have taken the APIs of Cimatron on the graphics, on the contour selection, on the geometry, on all of that, and created everything inside the Cimatron window. But to be fair and honest, Cimatron did a tremendous job in the API suite of functionalities by our development team in India, led by Ilan, and this was hand in hand with the progress of the development of the Cimatron Wire EDM Ficus team. At the end, I go back to the end of this slide. At the end, we will have an internal Cimatron installation altogether. The license will be managed by the Cimatron license, as Guy was showing. So it's a complete embedded product inside Cimatron, one-stop shop. There will be two phases to the product. One is an add-on to CAD-CAM or CAD-CAM, including one post-processor. This is a business decision. One post-processor is given for free, Any other post-processor is for fee. The post-processors are controlled by the Metalcam Ficus people. Cimatron does not develop any of the post-processors. They are all certified and secure post-processors by the Ficus team. They will be giving also the second level support to Cimatron. And the second implementation or the second product is the Cimatron Wire EDM standalone solution, which is based on decreased functionality of a Cimatron CAD. It's a Cimatron CAD seat minus assembly, minus drafting, minus catalog, plus Wire EDM. Once you're in, it's absolutely the same product altogether. So this is like a speed up movie of the integration. This is a toolbar. It might be later as a guide bar. It doesn't matter. It's a matter of implementation. On the left side, you are seeing what Ficus are calling the chem tree, which has the geometry, the technology, simulation. And in this example of the simple programming, that's it. You got the G code and it's done. Now the second movie is something which is more advanced called wizard and multi-geometry with corner treatment. So it shows more enhanced capabilities. I'm not going to go into that. Many of you or most of you know Ficus. It's a well-known product and many of you are selling or having your customers use Ficus. In this example here, this is the wizard for the Accutex, which is a technology where you can check all the options, and once you are done with that, all the programming is done with the scheme cuts and everything, and the detail at the corners, everything is there. And when you go to simulation, by the way, you see the gouges, or because this is additional to the geometry. And notice the simulation is the well-known ModuleWorks simulator, because Ficus are anyhow using ModuleWorks simulator in-house. And we get it part of their installation. It's not our ModuleWorks simulator, it's Ficus ModuleWorks simulator. But for the user, it's the same environment, same product. Moving on, this is an example I got from Dave Lindman from CTI on a real die plate. You see some different behavior of the user, but it doesn't matter. In this case, a lot of 4-axis cuts. If we go all the way to the end, this is the toolpath. And what I would like to show here mostly is the slug behavior. So this is the simulator. One of the options is a slug removal simulation. It's part of the standard ModuleWorks simulator. So you can see the slugs go up and down and verify that everything goes as planned. So in this case, the stock itself or the plate itself is stationary and the slugs go up. It doesn't matter. You can see the 4-axis cut as shown in this example. Just to briefly go over, it's 2- and 4-axis wire EDM programming. Select assist, feature selection. You can store smart strategies. This is all Ficus capabilities, realistic simulation, and precisely developed post-processors, part of the solution. Last is the fit control. And in its full name, it is called the physics-based fit control. It is a ModuleWorks MAL, seamless integration. MAL stands for Manufacturing Automation Laboratories, MAL. And you can check, you can Google this company. It's a well-established product, operational with existing customers in Europe, in Germany, in Turkey, in France, North America, mostly today with production in aerospace. It is implemented in NX, but not successfully because they have implemented the full-blown product and it's very difficult to operate and not user-friendly. We have taken the seamless path. So the idea is you put into the funnel the material characteristics, the tool with its all dimensional plus additional parameters, the stock, the machine with the taper and with the power profile of the machine, and the toolpath, and crunch it behind the scenes, and the result is an optimized toolpath. This applies in version 2026 on 3-axis toolpath patterns or procedures. So it works on rough, volume mill 2D, volume mill 3D, pocket, profile, finish, cleanup, and pencil. You can see that pocket and profile, which are in Cimatron legacy style, there is no problem to use those into the feed control. So we actually are agnostic with which input goes into the feed control. It's just a toolpath that, okay, we wrap all the data and send it behind the scenes to the engine. Feed control applies the calculation and sends the toolpath back to Cimatron as a standard Cimatron toolpath. You can then navigate, post-process, simulate, seamless as any standard Cimatron toolpath. The benefits in this case are utilize best the machine, protect the tool from breakage, protect the fixture from breakage, and even prolong cutter life. This is, as I said, a very advanced algorithm. Soon you will see some of the capabilities. As for utilization, it's very easy. Under machine control, there is the advanced feed control parameter. This is different to the adaptive feed control, which was the own Cimatron feed control applied in rough only. By the way, you can even checkbox that adaptive feed control. It doesn't matter because MAL, they don't care the source of the toolpath. They will do their own analysis and optimize any given toolpath. So once you click the access button, there are 4 tabs. Tool, where all the parameters, the geometrical parameters are coming automatically. This is why everything is grayed out, including a number of flutes, which is very important, but helix angle and rake angle, those parameters the user need to type in. And there is this graphic tooltip to explain what is helix angle and rake angle. Next tab is the machine. You select the pull down of the taper and select the profile of the machine torque, power, behavior at different speeds, at 600, 1200, 4000, and so on. If you don't know these, it has to be tuned first time with some support. I assume support for ModuleWorks, MAL engineers, which are available. And once, by the way, you have done it, you can save it because a specific customer don't have endless number of machines. So he can save his 5, 10 machines into some repository and then load the profiles back. The third tab is material tab. You can select the different types of standard naming like ISO, EIA, UNF, and so on. On each one of the standards, there is a list changing, and all are commercial numbers and commercial names of materials, all certified by MAL, something like 20,000 combination of materials. And they have done a numerous number of real test cuts on material, because please remember, this is physics-based feed control, okay? So it is all connected to physical material, and it was tested over for many years. Fourth and last parameter is the feed control. We are now implementing in V26 the automatic mode. There is the user-defined mode in V2027, not in V26. And as you can see, V27 will control the 5-axis, which is 5x production, tilting, auto tilt, and there will be the manual mode. Now it's only the automatic mode. So the user can select between conservative mode, balanced mode, and high performance mode. And this in the background triggers different parameters of behavior of the algorithm. Plus you can check all kind of air connection behaviors and minimum feed and maximum feed and so forth. Once everything is selected, the algorithm will work. And the algorithm has 2 rounds. First, it runs over the whole toolpath and analyzes and actually simulates what they are calling, simulates the process, which means every given step along the toolpath, they are measuring the load plus more other parameters, and based on the load, they are studying the nature of the toolpath. And once this is done, they go into the real run, and this is the second run. Based on the results of the first run, plus the input of the user for the slider and the other parameters, the algorithm will set the physical constraint given by the set of inputs, and feed rates are adjusted accordingly. This is a very smart algorithm. Here is an example. Okay, so first example is on a roughing. This is from the family of rough pocket profile. This is internally, it's a one family of operations. In a conservative mode, I'm showing here something that is not available for the users. Cimatron users do not see this graph. This is just to explain the behavior. I see we are out of time, so I'll shorten, Guy. So this is picked from Mach Pro, which is the full-blown application of MAL. What we are seeing here is bending forces. So bending forces go like that, and you can see here some peaks which are colored in red, which means those bending forces are beyond the conservative theoretical line. This means correspondingly the chip thickness in that area has to be dropped down in order to maintain the lower bending force. If I go further, in balanced mode, you can see that the theoretical line is above the theoretical line of that one. And if you go to high performance, the theoretical line is much higher. So the input plus the input of the user sets where the theoretical line of the maximal bending forces is applied, and accordingly the chip thickness is adjusted. And you can see here all the green area is gain in feed, gain in chip thickness, and you can see this is much higher than what we are having here. So users can start with conservative, and as they get more familiar with the application and gain confidence, they can go more aggressive. And the same goes for finishing family of functions, procedures, finish, clean up, pencil, same concept. That's the end of what I wanted to show. And Guy, if you would like to read out some questions, if we have time, it's okay. If not, we have to answer offline.
No, we can answer them or comment on them. Thank you, Alon. So let's start from the end because we are in MAL. So Danny asked, with MAL, does the user even need to input a real-ish feed rate in the procedure, or will MAL take over?
MAL will take over. So the user needs to put real feeds, okay? I wouldn't put in like 1,000, the standard Cimatron no-name feed. You should put in the feed which is in the range of this cutter and in the range of this operation. You shouldn't challenge the system with stupid input. Stupid input replies stupid output. So as the input is more realistic, the output will be more reliable and more robust. Yes.
And Ivan says our competitors are showing a graphics chart on the feed of the feed changes.
Yes, we had to take it by 2 bytes, Ivan. As I said, this will go in next version. We couldn't swallow everything in one version. Yes.
Okay. Julien is commenting on the new ModelWorks simulation and hopes that it will be able to handle MTM machines, multiple spindles or turrets in Cimatron.
This does not refer to the simulator, but to the application itself,
right.
Whether we do it or not. Yes.
Yeah, and MTM is currently not on our plans.
No. It's questionable. It's not in V26.
Yes. Still with you, Julien. So MAL seems promising. How does it differ from Sigitech VeriCut 4 solution or its standalone version optimizer, which is integrated into GIBSCAM, unless I'm mistaken?
Okay, I don't know about the optimizer in GIBSCAM, but I can say versus Sigitech VeriCut. I have benchmarked both products, Sigitech VeriCut 4s, for several months, and I have benchmarked the ModelWorks MAL. I could say they are quite similar in quality of optimizing. The issue was a business issue. We have a very good, appealing business offer with ModelWorks, which reflects to the end user. So, Julien and everybody, if you're interested, you will get the pricing from your sales managers, and you will see that your customers, it's in their capability to purchase this option. While with VeriCut Sigitech Force, it was something that was putting our price list upside down, and it was not realistic.
Okay. Danny asked, when will Ficus plugin will be available?
Yes,
you can answer, Guy.
I'll answer this.
Okay, Ilan, go ahead.
Yeah, to prevent any confusion or misexpectations. This project is experiencing difficulties. This is the first time that we have an external company writing with API inside our system. So we are resolving issues that we didn't encounter before. It's like licensing, translations, OLH support, and a lot of things. Everywhere. It's the first time. So I don't want to make excuses. Hopefully SP1, but sure yet. Well, later.
So hopefully SP1, maybe SP2, if I'm hearing you well, Ilan.
Yes, we really want to push it into the 2026 timeline. It was supposed to be in the release, but one of the hurdles was the new licensing mechanism until we got this stable with the old one. Now it's the new one. So there are issues here. I don't need to get into details. It's just it's delayed.
Okay. On GPU acceleration, so Lucas asks, is the GPU acceleration include on our complete system license, or we need a different license? And he adds that it's an incredible difference in simulation time compared to MachineWorks. So licensing?
In-house, yeah. I think in-house, if you have like a a demo license, it should be included, but for end users, it's an option.
Okay. It
But
answers the questions.
in order to test it, you have to have beta 2. It doesn't appear in beta 1, only beta 2. And even it's not so stable in beta 2, so you should be expecting better results in beta 3 or official.
Okay. And Julian asks, does ModelWorks offer ready-to-use digital twins for the machine simulation?
It's not a ModelWorks issue, it's a Cimatron issue. Cimatron needs to provide the machines. So if the machines are built properly, you can say this is a digital twin. Other than that, we do not use any of the library of ModelWorks. It's all Cimatron customers' existing machines. I hope I'm answering to Julian.
Okay.
If you have one more elaboration, if you have a new customer, Julian, and you are selling a kern machine, you could go ahead and get a nice developed model from ModelWorks. Maybe Cimatron will have anything in the library, and then it's a digital twin. So it's a valid point, it's a nice point, Julian, to have some off-the-shelf ready machines. But I think it's not the method Cimatron is using, because, for example, in Germany, and I'm sure also in other countries, each customer have some different slight changes, you know, in the tool change, in the conveyor, in the table construction or anything. So there is no any one machine similar to the other. So I would go very, very careful here.
So just to enhance on this point of machines with the machine simulator, this is a very important point. Thank you for bringing this up. We are working on providing two tools here. One is the ability to create a machine from scratch, so any user create a machine, and more important is the conversion of existing machine in Cimatron from the MachineWorks format to ModelWorks format, so everyone could use their own data and systems.
Yes, I mentioned that in my presentation. Yes, Ilan. Yeah, Julien confirms the answer.
Okay, the final question is about training. Have you planned internal training to use ModelWorks Machine Simulator? And Andy joins this question. So clearly, training is not just for ModelWorks Machine Simulator. It's a general question about training in general of new functionality, and this is definitely needed. We'll have to see. Probably if specifically we need training for specific topics, we'll have to see how to accommodate, maybe prepare a movie or any technical doc to explain things. The online help should be updated. That's a given. That must be part of the version, of course, as an immediate answer to questions. And of course, we are ready, to any question to answer. Also, on a webinar can be even to answer some questions in this regard. Yeah. Okay. Great. Okay,
guys. Thank you.
Thank you all. Thank you very much for attending. Thanks for your time. And thank you to the team that presented all the great functionality. And yeah, give us the feedback, use the versions that we supply. Thank you.
Thank you, guys.
Thank you very much.
Thank you.
Bye-bye.
Thanks very much. Bye-bye.
Bye-bye.
Thank you.
Good to
Bye.
see everyone.
Thank you.
Bye.